In this video I like to talk about how to find resultant of forces, or if you have a couple of forces, 2 or 3 forces, we want to find where the outcome would be. Let me just to explain a little bit in detail. Assume this is a river and we have a boat here. So this boat is affected with 2 forces. One force is the force that's coming from the engine of this boat, which is pushing this guy to go like this in this direction. Now I'm going to call this one F1. The force F2 is coming from the wind. So the wind is blowing and then the wind is coming, look like this. Force F2. That's the wind direction. So the question I have is that if the boat wants to get from A to B, what should the driver do? What should the person in charge needs to do? So if he steers straight, you would see that this boat won't ended up going straight. It will go as the resultant of these 2 forces, which would go somewhere here. It's not going to go straight. So this is what we call it, resultant force. So if we have 2 forces, we have force F1, we have force F2, the outcome would be resultant force. But we know mathematically Fr is not the sum of F1 plus F2 because they have a direction. So you can't simply add these 2 together unless they are in the same direction. So if F1 and F2 they are pushing like this, then I can say Fr is equal to F1 plus F2. If not, how can I calculate it? So there are different approaches to do that, but the simplest approach called component method. So in the component method, if you have as many as forces that you have, you can say if you have force F1, you have force F2, and any other forces. So that's what we do the approach. The first one is that step 1, we break forces into X and Y components. In step 2, we can say Frx, resultant force in X, is equal to sum of force in X, which is equal to F1x plus F2x plus whatever they are, and then same thing, Fry is equal to sum of F of on the Y, which should be F1y plus F2y. So the reason is that because F1x and F2x, both of them are component in X and Y, so I can simply add them together. Same thing here in F1y, F2y, I can add them together because they have the same property. So in order to find the resultant force in step 3, we can simply say that Fr is equal to root square of Frx to the power of 2 plus Fry to the power of 2. When I solve the example, this stuff will be more clear for you. And then theta, the angle between Frx with the angle between the resultant force and the x-axis, can be calculated as tangent inverse of Fry over Frx. So we will follow this step, this method called component method. So let's look at the first problem that we want to solve. In this problem, the force F1 is pushing upward as 800 Newton, and then the force 600 is pulling upward, the other force is pulling downward. We want to find the resultant of these 2 forces. So what I'm going to do is that I'm going to go the steps that I listed there, step 1, 2, and 3. So in step 1, I need to break forces this is F2, not Fr. So F2 is equal to 600. So step 1 is to break forces in X and Y. So force F1, I need to find F1x and F1y, and same thing here for F2. I need to find F2x and F2y. Okay, so f1 is in the direction of y, so f1x is 0. f1y is 800. That was easy. For f2, the force f2 is neither in the x-axis neither in the y-axis, is somewhere in between. So as we discussed in the chapter for trigonometry, we know that the opposite, we are looking for the opposite. We want to find how much the opposite of it is and how much the adjacent is. So adjacent is actually f2x, and then the opposite is f2y. Now, if you remember, for adjacent, we used to use cosine, and for opposite, we used to use sine. So in this problem, I can say the adjacent, which is f2x, is equal to 600 cosine 30. And then for y, I can say 600 sine 30. Now, the only thing that I should make sure that I take a note of it is that f2 is pointing downward. If you look into here, so it's pulling downward. So in the sine, I have to say f2y is minus 600 sine 30. Okay, in the next step, step 2, I want to find frx and fry. So frx, resultant force on the x, is sum of f of x. fry is sum of f of y. In this example, so sum of f of x would be f1x plus f2x, which is equal to 0 plus 600 cosine 30, and then on the y is 800 minus 600 sine 30. So if you calculate this number down here, you will get, so 800 minus almost 300, you get 500 here, and then 600 cosine of 30, I'm putting in the calculator, I'm getting 519, almost 520. So in order to see what's going on, so I'm gonna picture it like this. So on the x, I have 520. On the y, I have 500. We know from Pythagorean that the resultant of these two, which is the resultant of these two, would be fr, which is root square of frx to the power of 2 plus fry to the power of 2, which is equal to the square of 500 to the power of 2 plus 520 to the power of 2. So this will give me the value for, fr, which is fr is equal to, I can calculate that, which will be close to 1,000, so on 900 something, and then theta is equal to tan inverse of fry over frx. From the picture, I can see it is close to 45, but could be less, could be more. So you can actually calculate it to see how much exactly is at less than 45 degrees. In the second problem, and then in the second problem, I got into the situations that I have three forces, and one of the forces is actually, they did not give me the degree of it, but they give me the ratio of it. So in this example, the f1, in order to find f1x and f1y, because they give me each side of it, you see the ratio of this, so we need to use similarity between triangles. So the small triangle and the big triangle. So the big triangle here is f1x here and f1y here. So if I use similarity between triangle, I can say 30 over 5 is equal to, so the big one, the big triangle, which is 30 over this little triangle here. So I'm going to make the little triangle yellow so you can see it. So 30 over 5 is equal to f1y over 3 is equal to f1x over 4. Then if you cross multiply and solve for them, you will get f1x is equal to 30 times 4 over 5, which is 24, and f1y is equal to 30 into 3 over 5. The answer is 18. Again, one of them is going negative. We know that on the x we are going negative to the negative side, so I'm going to put this guy negative. So f1y, sorry, f1x is minus. So if I simplify them, f1x minus 24, f1y is equal to 18. On f2 is down here. The x component would be f2 cosine 20, sorry, the y component, because the y is adjacent. So if you look into 20 degrees here, the y is adjacent and the x is the opposite. So opposite will be f2 sine 20. So I'm going to simplify it. The value for f2 is 20, so I got 20 cosine 20 for y, and for x I got 20 sine 20. So I'm going to use the calculator to see how much they are. So I got 20 cosine 20 and then 20 sine of 20. Okay, 20 sine of 20 is 6.84. 20 cosine 20 is 18.8. Look into the sign of them, so I can look into here, say f2x is equal to, is going to the negative, so it will be minus 6.84, and f2y, which is going into the negative again, minus 18.8. I'm looking into f3. f3 is actually equal to minus 50, so f3x is minus 50, sorry, plus 50 is going in the positive side, and f3y is equal to 0. So this is step 1. We break the forces in x and y component. In step 2, I'm going to add them together. So step 2, frx is equal to f1x, f2x, and f3x, which would be minus 24. Then f2x is minus 6.84, and then lastly is plus 50. fry, which is going to be sum of y, f of y. On the y, I have 18 for f1. I have minus 18.8 for the second one, and I have 0 for the third one. So if you add up this stuff, you get minus 0.8. In the other one, we'll get something positive. So whatever the value here is, now we can find f of r is equal to root square of those two. You know that this guy is frx, and this one is fry, and then the theta is equal to tan inverse of fry over frx. So this could be a slightly hard tutorial for introduction to engineering, but I want to open up your mind into a tutorial for mechanical engineering, that they are dealing with forces, they are dealing with the magnitude of the resultant force, where it's going, how much it is, what angle it has it. Thank you very much for listening.